welcome to my channel. Today we are going to look into another Leetcode problem, binary tree zigzag level order traversal, and this is a medium level problem. Let's see what are the conditions. So we have to do the traversal, and we have to visit each node in a breadth first search manner, in a level order, you can say. And the thing is, the condition here is we have to do it in the zigzag manner. For example, from left to right, then right to left for next level, and alternate between. So you can see that we have an input of 3, 9, 20, null, null, 15, 7. So that's how this tree is formed, and the output should be 3. That is, first level is 3. And next, in normal binary breadth first search, we go, the output will be 9 and 20, but since it is a zigzag manner, we'll go in the opposite direction. So the output is 29, and next again we have to go from left to right, that is 15 and 17. So this is how it will work. So let's look how breadth first search actually work in binary tree first. Okay, so I have here a binary tree representation. It's the same example from the Leetcode problem. So let's see how the breadth first search actually works. We need a queue to work into the level order traversal, because the queue is first in, first out. So let's see how we can do it. So first we have a queue, and we have to have an initial value or the initial node in the queue to start with. So first we'll put the 3 at the first node, and that will be our root node. So what we'll do next is we'll pop this 3 out, and we'll do the pop. We have another array here. That means this node is visited, and after we pop, we'll check for these value of its, and the value of its is 9 and 20. So we'll put those values in the queue. Later, in the next iteration, what we'll do is we'll check for we'll pop the 9 value, okay, and put it in our array. And after we have popped the value of 9, we'll look if we have any children to 9. If there are no children, we'll move to the next node, that was together with 9, and that was 20. So we'll go ahead and pop this 20 and put it in our array. So this is 20, and we'll check if 20 have any children. If yes, we'll put them in the queue again, 15 and 17. Okay, so next we'll pop 15 and we'll put it in our array, and in the next level we'll pop 17 and put it in our array. Okay, so this is how the level order traversal work. So we'll have these values 3 and 9, 20, and then 15, 17. Okay, so this will be the original binary tree level order traversal. But the problem here is this is the normal level order traversal, and the question asked to go it in this exact manner. So our output should be on the first level as 20 and 9 instead of 9 and 20. So how can we achieve that? So if you look closer, we have to reverse the order only in the odd level. That is this first level, that is at the 0 index, the order will be correct. Then in the next first index, so it is an odd value, odd level, you can say. So we have to reverse our output, so that we get 20 and 9, and again in the even order we see that the order is in the correct form, that is 15 and 17. So I think the modulus to 2 logic should work in this case, and we'll see more while coding. I think when we code, you'll get the better understanding in how it's working. So here we are with our problem. Let's see how we can code. First, we have to always check up the exit scenario. So we should check that dot if root is not equals to nil, then only proceed, else return from here. Okay. So what we need is, as we discussed, we'll need a queue. So in Swift, queue is basically an array, and it will be int. Okay. And initially we have to declare the root as like I said, we need at least one node in our queue, so we'll take the root as a root node. Okay. And next we need some results to store the results, and it will be of type array of array int. Let's do it empty for now. Also, we have to maintain some um, counter to increase on each level. For that, we'll take a counter and set it to 0. Okay. uh, what else do we need? I think we are good for now. Let's go ahead and write our while loop. So we have to check while q is empty. So while q is not empty, or while run the while loop until the queue gets empty. So for now we do have one node in the queue, so we'll go inside this. Okay. And we'll also need a variable to store this array. Like for every level we need an array, so let's say that as current level equals to, that is an int array, and it will be empty. So you will be needing a for loop in 0 to q dot count to look through our queue. And like we saw earlier, in the queue we have to first pop the first element and then check for its children and put those children in the queue. Okay, so for popping logic, we'll take as current node, that is the one that we are popping, equals to q dot remove first. Okay, and we'll check if current node dot uh, dot left, so we have it here left and right nodes, is not equals to nil, then we'll put that in our queue. Okay, dot append current node dot left. Okay, similarly we'll check current node dot right nil, then we'll put node dot right. Okay, for the next logic, we have to check whether the level is even or odd. Based on that, we'll switch the places of the elements in the array. So here, for that, we'll check if counter modulo 2 equals to 0. That means this is an even level, else in the odd level. So in even level, we just have to append uh, our uh, our nodes to the queue, and what we'll do is current level dot append, and that will be current node dot val. This is, we have to force unwrap it. And in case of odd. Okay, let me write this first. Current node dot val at 0. Okay, so in case of even, we'll simply append the current node value to the current level, like in here, 9 and 20. But in case of the even, in case of the odd, we have to insert the values at the first position so that it is reverted. So in this case, it will be 20 comma 9. Okay, so this is how the logic will work. It's not that difficult. It's just have this logic that is different from normal breadth first search. Okay, so after once this is done and we are out of the for loop, we have to increment the counter. Okay, and we have to store our current level in the results. So we have to append it in the result. It will be append current level, and we simply return our results once this whole thing is executed. Okay, so this is how the code for zigzag level order traversal works. It's not that difficult. If you go through it once, I think it's easy to understand, and if you know how to do breadth first search, then it's not very different. It's just this logic that is the extra one. Let's see if this works. Okay, there are a couple of errors here. Uh, okay, and let's append it. Error value, optional type tree, node must be unwrapped. Value left. Okay, let's run it again. So it should be unwrapped. Let's see. Current node dot left and current node dot right. Yes, so it worked, and let's try to submit it and see. And here, oh, this is a pretty good runtime. I would say it is 7 milliseconds. So this is it for this video. I hope you guys like it. Please like, share and subscribe to my channel. I'll keep on posting new videos every time I solve any Leetcode problem, so it would be helpful for you guys. And yeah, so that's it for today. Thank you. Bye bye. Happy coding.